Hi, in this video we're going to look at the Cartesian coordinate system. Just a brief overview, we'll plot a few points, and then in the next video we'll look at a couple of applications. We'll find the distance between 2 points and also the midpoint between 2 points. Okay, so let's start off with the Cartesian coordinate system. This is a way of locating points in the plane. So if you imagine the surface here of this, the board here as a plane, we'd like to indicate points on it. Now this is a distinction from geometry, because in geometry we have points and lines and we can have polygons and things, but there's no orientation really. This idea was put on top of geometry by René Descartes and transformed mathematics as a whole into to really what we have today in terms of where we take functions and graph them. So this is really just the foundation of this. We have 2 copies of the real line. We have the x-axis, we put that horizontal, and we take another real line and orient it vertically like this, and that we call the y-axis. Therefore, any point, so put a point down here somewhere. This point could have coordinates A, B, and that locates it in terms of directed distance in the x direction and the directed distance in the y direction. So points are given as an ordered pair, A, B, where the first coordinate, so the order here matters, the first coordinate, the A, represents the directed distance in the x direction. So directed meaning positive would be to the right, negative to the left. B is the directed distance in the y direction. So positive in the y direction would be up, negative would be down. All right, and then we just take the values and march how far we need to go in the x, and then however far we need to go in the y. Where that is, label that the point. Okay, so let's go ahead and plot these. We've got the first point here at -2, 3. Okay, so the first coordinate is -2. That tells us we need to go -2 in the x direction. So if we start at the origin, we'll move 2 units to the left. 3 would be 3 units up. So 1, 2, 3. So 2 to the left, 3 up. There's our first point, -2, 3. All right, let's look at the next point, -9, 2. So here we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9 in x and 2 in y. Here's the second point. 10, 2. We'll go out 10 in the positive x direction, so over here, and then up 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2. 10, 2. And then 3, -3. 1, 2, 3 over, and 1, 2, 3 down. All right. So we've taken these points and plotted them. You can see that any point that we would pick, say this one, if we wanted to find what its coordinates are, we would count. So we'd go, all right, we're like 1, 2, 3 over, and we are 1, 2, 3, 4, 5, 6, 7, 8 up. So this point we'll call 3, 8. All right, that's pretty much it. Some other things we might want to mention that this notation, A, B for an ordered pair, is also the same notation we use for an interval. For example, we could talk about the interval from -2 to 3. Context will be important for distinguishing the two. If we're talking about a solution to a, say, an inequality, right? The answer, and we get this type of answer, yeah, that's an interval. If we're talking about points on the plane, it's going to be determined from the context. All right. Another thing we can talk about is a graph of a function, and you've probably seen them before. Those are collections of points. So a whole collection of points a comma b that satisfy the equation or function. So you might see your typical y equals x squared function, and you might see the graph for that. So I can put a few points on here. See the graph. It actually does not go through that point. Put it off to the side there. This graph, this line, this curve, right, is just a picture of all the points that would satisfy this equation. So anywhere this curve lives, so any point on the curve corresponds to an xy pair that solves this equation. Right? So when you look at a graph, right, when you see a curve, right, on the Cartesian coordinate plane, think of it as a set, a big set of these ordered pairs, input, comma, output, or a, comma, b, x, comma, y, for that curve. All right. In the next video, we're going to look at finding the distance between 2 points and finding their midpoint.